is show you one quick example of a complete the square problem that has a leading term coefficient not equal to 1.
Is this part of
My last? Yeah, this is just this. We left off. I would. You can turn in your homework. Now, like I said yesterday, there was one other style of these problems that we just didn't get. I mean, we probably could have forced ourselves into it, but we just didn't. I didn't want to rush through it. When you're working with completing the square, and your leading term coefficient does not equal 1, you have to do one thing first. Divide everything by the leading term coefficient. Sometimes it will, sometimes it won't. It just so happens that this example is a GCF and it works out cleanly. Now, if you divide everything here by 3, you get x squared minus 2x plus 4 is 0. Okay. Now, there is a time and a place for completing the square when your leading term coefficient isn't equal to 1. That does make sense when we talk about conics. And I mentioned a little bit about that yesterday with the hyperbola. We have the double-sided parabola, or when we get to an ellipse. We will convert from one form to another to be able to write these out via completing the square, but we're not doing that today. Okay? What we're doing today is just completing the square. So when I do that, I got rid of the first term coefficient. Lo and behold, my second term, or my b value, is even again. So it becomes really easy. What's the first thing you're going to do?
Track C.
Move it over. Okay. So far, so good? What's half of negative 2? Negative 1 squared is? What are you going to add to both sides? What's that? My term becomes x minus 1 quantity squared equals negative 3. Remember, whatever half of b is always drops into your term. It's a really nice trick. Square root both sides?
I equals I.
plus or minus root 3? Plus or minus I squared root 3?
Plus or minus I root 3? And then just move to 1. Okay? So like I said, completing the square with leading term coefficient equal to 1 is not scary. It's just one extra step. Okay? You could. You could. And then the benefit of using completing the square is because that second term is even. But if it's not, just quadratic formula if you can. So let's build into the quadratic formula.
Nobody. Oh, my discriminant. That's racist.
We're moving on to like, put your feet down, you bum.
Sorry.
Now, from what I understand, you guys have all worked with quadratic formula. And you guys laugh about it.
I don't remember.
We don't laugh here. I laugh a lot.
In the past, you guys have all worked with quadratic formula. It's a nasty looking little formula, but what's nice about it is that just like completing the square, it always works. But it does have its limitations. So let's just kind of jump into it by watching a video.
Oh no.
Let's-
Is this supposed to help us remember it?
Why do you use Internet Explorer?
That ain't good. Is this what
No, we don't want to see this one yet.
Everybody cover your ears.
We can see a guy in the back. You're giving too many guys.
The duck's song.
That's all.
With the parabola in his hand,
Sorry.
he said to help me. I don't understand and I've been having troubles. This problem's all my fears. So I took out my notebook and I wiped away his tears. With the quadratic formula. Quadratic formula. Quadratic formula. And it's negative b plus or minus the square root of b squared minus 4ac. Go over to a, over to a, over to oh, I couldn't factor it. I attacked the equation fast. Did I plug in the coefficients? Yep, you bet your ass me if I this problem's double drain. That's exactly when he stuck a knife into my brain. I said, why did you do this? Do you even care? Didn't I just help you? Didn't I complete your square? No, actually, quadratic formula. Quadratic formula. Quadratic formula. Quadratic formula. And it's negative b plus or minus the square root of b squared minus 4ac. Now my life is so short. Seen all the nights. Quadratics, cubics, quintics, quartics got the best of me. I hear dying, strange peace of me.
So maybe you do die.
Knowing that if I'm my stuff on for all the world to see. Oh my God! The quadratic formula. Quadratic quadratic formula. Quadratic formula. And it's negative b plus or minus the square root of b squared minus 4ac.
All together.
Over to a, over to a, one more time. Quadratic. Pretty way down. Plus or minus the square root of b squared minus 4ac. Over to a, over to a, over to a, over to a.
One can't do things with a guitar, Mr. Murphy.
Now,
Can we watch the Dutch one?
it gets even better.
The quadratic jingle.
Watch the guy in the mirror.
This one involves 2/8.
X equals absolute plus or minus root b squared minus 4ac all over 2a. What do you say? X equals absolute plus or minus root b squared minus 4ac all over 2a. Taught by Mr. Murphy.
All right, so by now you probably have heard that yes, there will be a project.
No, so this is the first I'm hearing of it.
All right. Well, the other classes I figured might have said something by now. You have 2 weeks from today, completely optional, to create your own.
Video?
Your own song, whatever, performance. That first one, I don't know who made that. I found that on the internet. I have no idea. I think it was Jack Black's voice that was singing.
Yeah, that's right.
I think it was him, but it's up to you. Working groups of 4 or 5 maximum. That one was just. I was dying. I was in tears when I saw it for the first time because if you know Mikey and Maddie, that was their dad making guacamole walking behind them, and he's just kind of like. And if you watch the video, you see Jack outside as Mr. Leopardo walks by. Jack's like, no! He's like screaming like this to him, and Dad's just like. I'm gonna eat some guac. And I told me, I talked to him later about it. He's like, I was making guacamole. So he's eating guacamole. It's really funny. But yeah, that was. What's that?
You can see him in the mirror.
Yeah, you can see him in the mirror. It's pretty funny. But yeah, I do this every year when we talk about quadratic formula. I've been doing it for 5-6 years. I let people come up with their own little jingle. Clay is so excited. Jumped out of his chair.
I'm trying to stay quiet. If I stay on cue, I stay quiet.
Wow.
Has anyone figured that out yet?
Like I said, it is an extra credit little project. I do make it worth your while. It's not like you're gonna get a gazillion points. But it is every let's see. Today's the. So 2 weeks from today is the 3rd, I believe, October 3rd. And make sure it's some sort of a format we can play, whether you guys can save it, put it on a YouTube, send me the link, or if you need to email me the file or something along those lines.
Do you have any performance?
No, it's got to be recorded. I'd rather have it recorded. Then we'll show it in class on that day. Get a good laugh.
Okay.
All right? Does that make sense? Yeah.
Yeah.
Does that have to be people in your class?
You have to be in it. Other people did ask if somebody else, can help out or whatever. That's perfectly fine. Other people in other classes also asked, can they work with somebody like in one of the other sections that I have? Fine. If you guys want to work with somebody in 3rd hour, that's cool. Or, so you can work with someone in 6th, 7th. People have already asked, can we work with other people in the other courses? Not a big deal. I have no problem with that. The Leopardos, they weren't in the same class. Or Hunter, they weren't all in the same class. So yes.
What about the regular classes?
They won't get the extra credit for it though.
Okay.
Just don't tell them the score.
Yeah, exactly. Questions about that? Yes, ma'am.
What's the official date?
The 3rd.
Okay.
It's in October. All right. No other questions about that? I don't think no one's ever made an animation, so if anybody's good at that, that'd be kind of cool. Never seen that before.
Does it have to be?
It has to be about the quadratic formula. Some performance of it. Most people remember the quadratic formula as the following, and
Does it have to involve any more than the actual formula? Do we have to just tell anything else about it?
not really. I mean, it doesn't matter. Yes, ma'am.
What did you say the maximum for people?
I don't want to do more than 5, because that's what I think most people really have, 4 or 5 tops. Otherwise, it just gets to be who's not doing the work, who's doing it, type of thing. These guys were all, they were all dancing. Jack, he was like, we'll talk. So quadratic formula. The quadratic formula, I'm just going to go through this real quick, give you guys some problems to do over the weekend and call it a night here. So bear with me because I know we only have, 25 minutes left, so we'll get through this real quick. Quadratic formula is another way of solving to get your zeros of any quadratic function. It's nothing more than plucking coefficients. It works for every single quadratic function that you have, just like completing the square does. There are better times to use it than others. Like I was saying yesterday and today, I would personally complete the square if my b value was even. If it wasn't even, I'd use the quadratic formula. That way I don't have to deal with the fractions. Okay. So let's walk through what it looks like, and this is how most of you guys probably remembered it. Ready? X equals negative b plus or minus square root b squared minus 4ac all over 2a. And that's why I don't sing.
Do it again.
No.
You clap for him, he does it again.
Yeah.
Encore.
Yeah.
Oh, cool.
No. So you guys have all seen that before. You probably heard the bad Pop Goes the Weasel version of it. You cannot use that version. It's copyrighted because I performed it first. And you know why I know that? It's on tape.
Oh.
I didn't see it.
I used to I didn't know myself singing it.
Lawyer.
Oh, you know all the things.
No, this is just this is quadratic. That's the generic form of a quadratic equation. What you're looking at there is you're plucking out coefficients. So let me walk you through how you set one up real quick. Talk about what's called the discriminant, and then call it a day. Real easy problem to set with one of these. There we go, slowly but surely. I'm going to use this as my example for quadratic formula. I'm not going to simplify anything out. I'm just going to go ahead and pluck out coefficients and go for it. In this case here, it is not written in the standard form ax squared bx plus c. The c value is on the other side. So when you're dealing with quadratic formula, you want to have a side equal to 0. Because what you're doing with the quadratic formula is you are finding the zeros. You're finding out where it crosses the x-axis. What I normally tell students to do the first couple of times is list out your values. It takes an extra 3 seconds out of your lives. I know.
Like a carpal tunnel.
You'll be okay.
I could have used those 3 seconds.
I could have used those 3 seconds back to continue this problem, but that's not what we're going to get at. So, that's good. Zing! Wait, hold on. Just read it.
That's a term, right?
Sorry, I'm sorry. Anyway, so now we go back, and if you do not have the quadratic formula memorized as of yet, you want to sing it again, so everybody sing it with me. X equals negative b plus or minus square root
Drum solo.
b squared minus 4ac all over 2a. Ladies and gentlemen, please stay in school because your singing sucks. Use your coefficients, negative 24.
Negative B. Oh, wait, never mind.
When you do these things, don't type it all into your calculator. You're going to do it wrong.
It won't work.
Okay? What you always want to do when you're working with the quadratic formula is you're solving it out. Take care of the discriminant first. What is the discriminant, you may ask? Well, the discriminant is all the junk underneath the radical.
So,
The discriminant, I spelled that wrong, is the b squared minus 4ac. The discriminant is all the stuff underneath the radical. The discriminant has a really nice meaning to it. it tells you how many zeros you're going to have and of what type. You guys probably remember this from algebra, and I heard this earlier today. If the discriminant equaled 0, the b squared minus 4ac, when you simplify that, if it equals 0, you had one solution. So if the discriminant equals 0, you have one real solution. If the discriminant was greater than 0, in other words, positive, you had two solutions. You had two real solutions. Yeah. Oh, you're not worried about, you're just looking at what's underneath here. Okay, and you'll see it here in a second. You have two real solutions. And now if you think back when you first looked at this before, if it was less than 0, you guys probably were taught that there was no solution. Get way up. Now, if it was no solution way back in Algebra 1, now there is a solution because we know about imaginary numbers. So now you have two imaginary solutions.
I used to lush.
Okay? It's nothing different than what you have seen before. You guys talked about discriminant in Algebra 1 being two solutions, one solution, or no solution. Well, your Algebra 1 teachers were lying to you.
Come
Well, she lied to you. I'm sorry.
With my life.
All right. Now, whenever you're working through, this is kind of a larger example. Well, to be honest with you, I wouldn't use quadratic formula with this problem because to make it easier. Yes, I would have completed the square. But when you do all this stuff underneath here, what do you get underneath the radical? What's the discriminant? 200?
Let's do some math.
What is it? 252? Okay. So you wind up with negative 24 plus or minus the square root of 252 over negative 6. Are you okay with that?
Yes.
All right. Now, at this point, you'd have to simplify out your root 252. I don't know. 16 goes into it, maybe? 36?
I forgot what the
7.
secret.
Take 252 divided by x.
All
Sorry.
teachers, please excuse all fans, cheerleaders,
Six or
Seven?
Fix these little things.
6 or 7? All right. So you get negative 24 plus or minus 6 root 7 over negative 6. The homework stuff here. It's on, what is it, section 5.6. It's page 296. Can I steal your book real fast, please? Because I know a lot of people are going to mail it. Sorry, I tried to go faster so you guys can go. Yeah, I know everybody else does, but I'm trying to get the game out.
Mathematically. Like technology.
46 through 58, please. Yeah. With those problems themselves, they're saying to choose any method you want. So it's a matter of, do you want to complete the square? Do you want to use quadratic formula? Do you want to factor? So it's up to you to make the decision. I'm not going to tell you which one is better, but I will say that if your b value is even, complete the square. All right? Julio. See you guys.
Listen to your board.
It's not, something's wrong with it. I'm not sure what. Okay? The rest of you yahoos, you have work to do. Make the work go.
The rest of us.
Can we keep doing that one?
When you simplify that out, it's over negative 6. So your answer winds up being, when you simplify it out, it's going to be 4 plus or minus root 7.
Why is it? Because 24 divided by 6.
Okay?
Negative 6.
And now and this is where people take a second to go, wait, what happened to the plus minus? Well, everybody agree that you have two solutions here. You have negative 24 plus 6 root 7, negative 24 minus 6 root 7.
Yeah.
If I divide everything by negative 6, well, a positive divided by a negative is a negative, and a negative divided by a negative is a positive. It just kind of goes away.
It doesn't even matter. It's gone.
So 4 plus or minus root 7 is the answer.
Is this the case where you can't simplify?
Did you show the homework thing?
I I was just trying to show you how you pluck out coefficients. I don't,
Yeah, at all.
I'm not really worried that you.
You got it.
Wait, so on every single one, the plus and minus doesn't matter?
No. Okay, let me rephrase that. You have to have plus and minus because you're taking a plus minus a square root. When you're dividing by a negative, remember, this is what really is happening here. You have two answers in there. You have negative 24 plus 6 root 7 over negative 6, and negative 24 minus 6 root 7 over negative 6. Which, if you break it apart as two separate fractions with the common denominator, you get 4 minus root 7. I break it apart. Oops. And I have 4 plus root 7. When you distribute the negative, you just go into both terms. That plus minus doesn't change because the negative. It just goes as a plus minus, it's not minus plus. Does that make sense? Okay. I'll give you a second to help him out real fast.
Mr. Murphy. Mr. Murphy. Yes, sir.